Statistics. Now we are going to see some advanced things here where we have the statistical measures of data. So there are two where we have of the measure of the central tendency. We are going to see here to basically in this lesson the measure of the central tendency and also measure of dispersion, or what we call the spread. Now, when we talk about this measure of central tendency, this locates the center of a given set of data, and this includes mean, median, and mode. So why do we say these are measure of the central tendency? Because if they give you some distribution of given sets of data, this one at least they will show you a roughly balanced measure for all that data will be with. Then the mean of the discrete data. We have seen what the discrete data is, and we have seen how also continuous data is. Now we are concentrating on discrete data here for its mean. Given the data x1, 2, 3 up to n, then the mean we say we sum all these x values, then we divide by their number, which can be simply summarized into a formula. It's the sum from I up to n xi, where xi is 1, 2, 3 up to n. So from 1 up to n, then we get 1 over n of the whole. Okay, this one is the note that's coming after there. So let us see the measure of median of the discrete data. This is the middle value when data is arranged in ascending or descending order. If the number of data is odd, then the median is the middle value, and this position is given by this. Now this formula will help us locate it when data is either the number is even or odd. This formula we are going to see how to use it next lesson. Then mode of discrete data. This is the number that occurs most frequently in a given set of data. So when you have a number that occurs most times, then that one becomes our mode. Let us see measure of a spread. Measure of location alone don't give aggregate description of data. The measure of dispersion gives us how far data is dispersed from the median. It gives range, variance, decimal standard deviation, percentiles, quartiles, etc. Let us start with the range. The difference between the largest and the smallest data points. So when you get the highest value minus the smallest value, that's how you get the range. This is very easy. Then variance, this is the mean square deviation from the mean. What we do, we get those sets of data, we subtract them from the mean, then we square it. All of this, our variance is always denoted with the sign, sigma squared, we call it sigma squared, and the formula, and we summarize in that order. Sorry, this is the 2. So this is a 2 there. Then sigma squared, we can summarize this formula like this. We sum xi minus the mean, then we square from I up to n. Is what it means there. Or there is a lot of algebra that went wrong so that we reach this level there. Okay, so what next after that? After that, we come to the standard deviation. Now this is the most important because this one gives you the details of what that data is all about. This is the square root of a variance. Now, this standard deviation, when it's small, it implies that the sets of data we are having is reliable. Whenever you have a small SD or standard deviation, it means that that set of data you have is giving you reliable information. When it's big, it means that it's not reliable to work with. In simple terms, that's how we can use the standard deviation to interpret or analyze the sets of data given to us. Let us go to quartiles. This divides the number of observations into 4 quarters, i.e. the lower Q1, the middle Q2, and then this middle one is sometimes what we call the median, and the upper quartile Q3. The interquartile range is the difference between the upper quartile minus the lower quartile. Then the semi, I'm missing here the semi interquartile, but semi, as we hear semi, we just get the semi interquartile range, we get the interquartile range, we divide it by 2. Then the position of the first quartile is 1 over 4, n plus 1. Then the third quartile, the third quarter, 3 over 4, n plus 1, the nth position. Now the middle quartile, that one is the same as the median, as you can see in here, the same as the median when we reduce that to over 4. Now, to obtain quartiles, strictly to obtain quartiles, our data should be arranged in ascending order. Strictly, the way we are dealing with quartiles. We are going to see the deciles and percentiles also, then try out some examples. See you there.